Good morning, everybody. Welcome to IB Buddy Grade 9 Mathematics. Topic 7, Changing Dimensions. Let's just get right into it. What is perimeter? Perimeter is the total length around a 2D object. So essentially the sum of all sides of a 2D object, like a rectangle in this case, square, trapezoid, etc. So what is the rule for changing dimensions for a perimeter? So the amount the sides are getting multiplied by is the amount the perimeter is getting multiplied by. So example, a rectangle with side lengths 9 centimeters and 4 centimeters are doubled. By what factor does the perimeter increase? So we have side lengths 9 and 4 centimeters, and the perimeter is 26 centimeters. Because it's essentially the sum of all the sides. So this plus this side plus this side all equals 26 centimeters. So now if we double all the sides, how much will the perimeter increase by? So first what we do is we see that all the sides are being multiplied by one number, which is, in this case, 2. So what we do is we get 2, and we now know that the perimeter is being increased by a factor of 2. So what we do now is we grab the original perimeter, which is 26, and we multiply that by 2 to get the new perimeter, 52 centimeters. So that essentially means the new rectangle in which all these sides are being doubled, the new perimeter will be 52 centimeters. And at the end of the video, we'll be talking about why that's the case. All right, now area. So what is area? It is how much a shape covers, like painting it. So we have this, on the yellow, we have like a sort of border, and inside we can sort of paint the whole inside of it, right? So the amount we can paint inside that shape, that is the area. So the rule is the amount the sides are getting multiplied by, the resulting area is that amount squared. So K, let's introduce K. So K is essentially the scale factor. So how much the thing is getting increased by or decreased by. So if it's getting reduced by half, it will be 1/2. K will be 1/2. Or if all side lengths are getting multiplied by 2, then K would be 2. So what we do is, let's look at an example. So a rectangle has dimensions 6 centimeters by 5 centimeters. Both sides are increased by a factor of 3. By what factor does the area of the rectangle increase? So here we're looking at area. So we have drawn the diagram in blue, 6 centimeters by 5 centimeters. And so area is length times width, 6 times 5, that's 30 centimeters. So area is 30 centimeters. So we're trying to find how much does this area increase by when these side lengths are tripled. So we see that all the side lengths are tripled. So what we do is we take the scale factor, which we introduced was K. So K is 3. So we grab 3 and we square it. As it says, K squared. We square it. 3 squared equals 9. Thus the factor is 9. So that means that the new area of the rectangle that has been tripled in side lengths will be triple this original area. So we just plug in the original area, 30, and then times that by the factor, which is 9, and we get the area as 270 centimeters. AKA, the new area will be 9 times bigger than the original area. Now let's go on to surface area. So the surface area is the total area covering a 3D object. So a 3D object could be like a cube, cylinder, and the rule is the same as area. And we'll get into why that is at the end. So here we have an example. A cube has an edge length of 7 centimeters. All edge lengths are reduced to half their original size. By what factor does the surface area of the cube change? So here we see that the surface area, the edge length is 7 centimeters. So you can see that this is 7. And essentially, it's getting reduced by half. So you can either do divide by 2, or you can do times by 1/2. They're the same thing. So 7 is being times by 1/2, aka getting reduced by half. And so we do the same as area. We grab what's being multiplied. So here we see it's 1/2. So we get 1/2. And essentially, we square 1/2. So 1 squared is just 1. And then 2 squared is 4. So it's 1/4. That is the scale factor, aka K. So now we know that the new cube, the new surface area of the cube that is being reduced by 1/2 is 1/4 of the original surface area of this cube. So essentially, the new surface area is 1/4 smaller, is reduced by 1/4 of the original surface area. Now let's go on to volume. So what is volume? It is how much space an object takes up. So as you see with area, it's like a 2D object you're painting inside of it. But with 3D objects, it's like pretend this is a can. So you're like filling it with soda. So how much soda you can fill up, or like just like anything, how much space it takes up. So the rule for changing dimensions is the amount the sides are getting multiplied by, the resulting volume is that amount cubed. So essentially, it's the amount it's getting multiplied by cubed. That is the factor. So an example, a cube has an edge length of 5 centimeters. Each edge length is multiplied by 4. By what factor does the volume increase? So let's first draw our cube. So we have a cube here. Not the best at drawing 3D images, so bear with me here. Do that. Okay, so we have a cube. Now the edge length is 5 centimeters. So 5 centimeters by 5 centimeters. Okay, so each edge length is multiplied by 4. So everything is being multiplied by 4. So what factor does the volume increase? So we know from k cubed, we find the factor that is being increased by. So we see that all the sides are being increased by this number, 4. So we grab 4. So if we have 4, and now what we do with 4 is we look at k. So k cubed. We cube k. So k is 4. We do 4 cubed, which equals 4 times 4 times 4. So then 4 cubed equals 4 times 4 is 16. 16 times 4 is 64 centimeters. All right. So now that we know that the volume increases, the volume is 64. Oh shoot, why did I write centimeters? Essentially the factor that it increases by is 64. So this, let's just say this is the regular volume. the new volume is 64 times the volume. So essentially, it's 64 times the new cube's volume is 64 times bigger than the original cube's volume. So when a edge's length is quadrupled, the new volume will be 64 times bigger than the original volume. All right, now let's get into special cases. So this is when not all side lengths are multiplied by the same amount. Wait. Now let's hop on to why. Why is it that these work? Like k and then k squared. Why is it k squared? And why is it like k cubed? Why is it like this? So let's first go into perimeter. So first of all, the perimeter formula for, let's just do rectangle in this case, is length plus length, because there's two lengths which have the same values, 9 and 9, and then plus width and width, because they also have the same values. And so in total there's 4 sides, length plus width plus width. And so now when we double these lengths, so let's just double these lengths, double, you can see how the plus separates them. So you see how these are all doubled. So that means that the resulting perimeter will also be doubled. So that's why it's just k, because it just remains at 2, because the plus separates them. Just here, just separate the plus just separates them. So it's just 2, and so the new perimeter will also be doubled. Same with tripled, quadrupled, any number. Now let's go into area. So why is it k squared? And why is it this is the rule? So if we go here with a normal rectangle, let's say, and we have the length as 2, width as 1. So if we do a, wait, cut this out. Okay. So the area formula for a rectangle, or for most things, for most 2D objects, is A equals length times width. So here length is 2, width is 1. So let's just simulate what would happen to the area if all side lengths were tripled. So this is the formula. So if all side lengths were tripled, let's just do 3 because it's tripled. Okay, so you see it's 3L times 3W. So now let's just complete it. 3L times 3W. If you don't know how to do it, you're just multiplying monomials. So you do 3 times 3, which is 9, and then L times W, which is just LW. Now you can see this 9. So that means that the scale factor will also be 9. So the area will be 9 times bigger than the original area. And we can see that with this. So the length of this is 2, width is 1. So the area is length times width, area is 2. So now when we triple it, length is 2 times 3 is 6. 1 times 3 is 3. So then here, length times width, 6 times 3, that's 18. And so let's see if this is correct. Is it really 9 times bigger? So we do the original area, which is 2. We times this by 9, which gives us 18. And yeah, that's true. It is 9 times bigger. So this, we do k squared because this 2 signifies that there are 2 dimensions that are changing: length, and width. So 2 signifies that there are 2 dimensions that are being changed: length and width. And so, as you can tell with surface area, there's also length and width. So we just keep the rule the same as area, because they're both talking about area. Now volume, we do k cubed because now it's talking about length, width, and height. Because if you have a cube, right? Or let's just draw a cylinder, right? If we have a cylinder, not gonna be the pretty cylinder. Let me actually draw something a little bit better. If we have a cylinder, right? So to get the volume of a cylinder, it is the volume, the volume formula for a cylinder is pi r squared h, right? Volume equals pi r squared h. So you need the length, which in this case is the radius. So we need this. We also need this, which is the same as the radius. So this is all radius. Length, width is the same as the radius, right? And then we also need the height of the cylinder, the height. So we're now talking about 3 dimensions: 1, height; 2, length; 3, width. So that's why it's k cubed, because we're talking about 3 dimensions. And so when you do this, it just it's how much it's getting multiplied by cubed. That's why this works. Now, let's move on to special cases. So, when not all side lengths are multiplied by the same amount. These are like special cases where, like, for example here, or let's go to the rectangle, where the widths will be multiplied by 2, but the lengths will stay the same or be multiplied by 4. All the side lengths won't be multiplied by the same amount, because for all of this, I'm talking about if all the side lengths are increased by the same amount. Here, I'm talking about when they aren't. So let's move on to this example. So a cylinder has a radius of 4 centimeters and a height of 12 centimeters. The height is tripled while the radius remains the same. By what factor does the volume increase? So we have the volume formula of a cylinder. So let's just draw a cylinder. We have a cylinder. As you can tell, I'm not the best at drawing cylinders, but I'll make it work. Okay, we have a cylinder. So the radius is 4 centimeters. So we have the radius, which is 4 centimeters. So that means this is also 4 centimeters. Okay. And then the height is 12 centimeters. So we have the height, which is 12 centimeters. So the height, this height, is being tripled times by 3, while the radius remains the same. So by what factor does the volume increase? So since the volume formula is V equals pi r squared 8 times h, so the radius remains the same, but you see how the height is getting multiplied by 3. So that means here, this is getting multiplied by 3. So you would do V equals pi r squared. And then 3 times 3h. And so if you know how to multiply monomials, you do that. So V equals, so this pi r squared times 3h is the same as 3 times pi r squared h. So V equals 3 times pi r squared h. You see how this 3 symbolizes that the volume, because volume equals pi r squared h. So if pi r squared h is multiplied by 3, that means the volume is multiplied by 3. So that means the volume will be tripled. The volume will be tripled. So the volume will be tripled if only the height is tripled. Now let's go with surface area. So a cylinder has okay, let's just draw the cylinder. Boom. Okay, so a cylinder has a radius of 6 centimeters and a height of 10 centimeters. Boom. 10 centimeters. The height is doubled. So here you have the height is doubled, but the radius stays the same. So by what factor does the surface area increase? So we have the surface area formula of a cylinder, and as you can see, the 2 pi r squared is essentially, so the area of a circle is pi r squared. So then 2 pi r squared means 2 circles. And where are the 2 circles in a cylinder? Over here and over here. These are the 2 circles. So I was talking about the 2 circles. This is talking about these 2 circles. And then the 2 pi r squared the 2 pi r h is then talking about, you see this body, the thing that's being wrapped around those 2 circles. So since in this formula we have surface area equals 2 pi r squared h plus 2 pi r h. So since the height is being doubled, we do this times 2. The h is getting doubled. And as you saw from our previous thing, this is the same as the whole thing being tripled. So here, if this height is being doubled, so if we add like here 2, that's the same as surface area equals 2 pi r. This stays the same because this is separated by the plus sign. 2 pi r squared plus, and then this 2 is the same as just 2 times 2 pi r h. So now that we know this, that means that the circles are not being affected by this increase in factor, like the doubling. The 2 circles are not being affected at all. But the surface area, the lateral surface area of the cylinder, like the body of the cylinder, is being affected. It's being doubled. So essentially, you just say that the lateral surface area, aka the body of the cylinder, the surface area of the body of the cylinder is being doubled, but the surface area of the two circles of the cylinder, this one and this one, stay the same. So you can also determine it not just by memorization, but also by formulas and knowing what's what. So thank you for listening. This is IB Buddy Mathematics Grade 9, Changing Dimensions, and I'll see you tomorrow.